Hello students, welcome to the subject of complex variable and partial differential equation. This is Dr. Ankit Acharya, and up to this we already discussed about case 3, case 1, case 2 and case 3 for particular integral. So in today's lecture we discuss about case 4. Okay, now what is case 4? Try to understand very carefully. Case 4 is, suppose your function f of xy is any function of ax plus by. So you can see that f of xy is g of ax plus by, any function of ax plus by. For that, you have to apply this rule. So 1 upon f of d dash into g of ax plus by, that is our particular integral. Try to understand the rule. First of all, 1 upon f of ab. Okay, so instead of d, I can take a, and instead of d dash, I can take b. Now, you can see that there are multiple integrations, okay, n times. Now, what is the meaning of n times? That means n is nothing but order of f of d dash. Suppose your equation is in this form like d square, d dash, d dash square. So what is your order? N is equal to 2. Okay. So you have to integration 2 times. Suppose your equation like this, d cube, d square d dash square, d dash cube. So that means your order is 3. So that means you have to integration 3 times. Suppose you have only d dash, so that means your order is 1. So you have to integration only 1 time. Okay. So don't be confused here. Here I already mentioned n times, and n is what? Order of f of d dash. G of v, dv up to n times. Okay. Where v is what? Ax plus by. So first of all you have to assume what is your v? V is nothing but ax plus by, that you have to assume whenever you find particular integral. Now again, suppose denominator becomes 0, so same rule you can apply up, that you have to multiply with x, differentiation with respect to d. So you will get f dash d dash, and take d and d dash. Instead of d and d dash, you can take a and b respectively. Okay. So let's try to solve some examples. So this is my first example, r plus s minus 2t, that is equal to 2x plus y raised to 1 by 2. So right hand side I have a function like ax plus by. Okay. So what is my a? Don't forget, a is equal to 2 and b is equal to 1. Okay. First of all, we find complementary function. So we know that r is this equation. I can write del square z by del x square. Okay. R is nothing but del square z by del x square. S is nothing but del square z by del x del y. And t is nothing but del square z by del y square. Okay, and that is equal to, I have 2x plus y raised to 1 by 2. So don't be confused. Now f of d dash, I can write d square, this is d dash, d into d dash minus 2 d dash square, that is equal to 0. So what is my function of n? That is n square plus n minus 2, that is equal to 0. Don't forget to write n is nothing but d by d dash. Okay, and I can easily simplify. So this is m plus 2 into m minus 1. Okay, so what are the roots? The roots are minus 2 and 1. Okay, so I can write complementary function that is f1 y minus 2x plus f2 y plus x. Okay, easy to understand. Now important thing is, I want to find particular integral. Okay, so what is my particular integral? Particular integral, that is equal to 1 upon d square plus d dash to d dash square. And what is the function? Function is, don't forget, function is 2x plus y raised to 1 by 2. So 2x plus y raised to 1 by 2. So first of all, assume what is my v? Assume v is equal to 2x plus y. Okay, v is equal to 2x plus y. And now we know that a is equal to 2. Okay, compare with ax plus by. So a is equal to 2 and b is equal to 1. Okay, so a is equal to 2, b is equal to 1. So that's why take, instead of d I can take 2. So 1 upon 2 square. So that is 4 plus 2 into 1. So 6, 4 plus 2, 6, minus 2 into 1 square. So minus 2. So 6 minus 2. So that is 1 by 4. Now because of degree of f of d dash, that is 2, because we have function d square plus d dash minus 2 d dash square. Okay, so that's why we have to integration 2 times 2x plus y, that is v. So v raised to 1 by 2, okay, dv, right? So now just you have to integrate this function 2 times. So 1 by 4, the first integration of v raised to 1 by 2, so that is v raised to 3 by 2 divided by 3 by 2. So I can write 2 by 3, okay, dv. Now this equal to, I can write here, okay, 2 by 4, so 1 by 2. So now I have 1 by 6, right? Now again integration of v raised to 3 by 2, so that is nothing but v raised to 5 by 2 upon 5 by 2. So I can write 2 by 5, right? So once again 2 cancel, so 1 by 15, 1 by 5 into 3, 15, and what is my v? V is nothing but 2x plus y raised to 5 by 2. Okay, so let's solve one more example. Next example is r plus 5s plus 60, that is equal to y minus 2x inverse. Okay, so first of all, what is r? R is nothing but del square z by del x square. What is s? S is nothing but del square z by del x del y. What is t? Plus 6 del square z by del y square, that is equal to y minus 2x inverse. Okay, so don't forget here we have a. A is equal to minus 2 because compare with ax plus by. Okay, so this is something function of g of ax plus by. So a is equal to minus 2, the coefficient of x, and what is your b? B is equal to 1. Okay, so don't forget a is minus 2 and b is equal to 1. Now first of all you have to find out the complementary function. So this is d square plus 5 d dash plus 6 d dash square, that is equal to 0. So I can write m square plus 5m plus 6, that is equal to 0. So m plus 2 into m plus 3. So roots are minus 2 minus 3. Okay, minus 2 minus 3 are roots. So roots are minus 2 minus 3. So the complementary function I can write f1 y minus 2x plus f2 y minus 3x. Okay, f1 y minus 2x plus f2 y minus 3x. Okay, now I want to find particular integral. So particular integral, that is 1 upon f of d dash. So what is my f of d dash? D square plus 5 d dash plus 6 d dash square. So d square plus 5 d dash plus 6 d dash square, and what is my function? Y minus 2x inverse. So y minus 2x inverse. Okay, now here we know that a is equal to minus 2 and b is equal to 1. Now when we take a is equal to minus 2 and b is equal to 1, instead of d and d dash, this denominator becomes 0. Let me show you. This is 4, okay, minus 2 square, so that is 4. Here we have 1. Okay, so 4 plus 6, 10, and in middle term we have 5 into 1 into minus 2, so minus 10. So denominator becomes 0. So we cannot apply. So that's why we have to differentiate and multiply with x. Okay, so 1 upon differentiation of d square plus 5 d dash plus 6 d dash square with respect to d. So that is 2d plus 5 d dash. Okay, y minus 2x inverse. Now I can apply the value of a and b instead of d and d dash respectively. So that's why x into 1 upon 2 into minus 2. So that is minus 4. Okay, plus 5 into 1. Right, and now order of this function 2d plus 5d dash, that is 1. Okay, so that's why only the first one integration v inverse. Okay, what is v? V is nothing but y minus 2x. Don't forget to assume v is nothing but y minus 2x. Okay, so that's why this equal to 5 minus 4, that is 1. So x into 1 upon v, integration of 1 upon v, that is log v. So log and the value of b, that is y minus 2x. So x into log y minus 2x. So this is the particular integral for this example. Let's solve one more example. So this is the next example of case 4. 4r minus 4s plus t, that is equal to 16 log x plus 2y. So first of all we find a complementary function. So I directly write f of d d dash. We know that r is d square z by del x square. So I can write 4d square minus 4 d square z by del x del y. So d square z by del x del y. So that is d d dash plus d dash square. T is nothing but d square z by del y square. So that is d dash square. Okay, the equation of m, that is 4m square minus 4m plus 1, that is equal to 0. So this is exactly 2m minus 1 whole square, that is equal to 0. So roots are, I can write 1 by 2, 1 by 2, repeated roots, okay, equal roots, and for that, what is my complementary function? f1 y plus x by 2 plus x f2 y plus x by 2. Now I want to find the particular integral. So we know that particular integral is 1 upon f of d d dash into f of xy. So f of d d dash, that is 4d square minus 4d d dash plus d dash square. So 1 upon particular integral, that is equal to 1 upon 4d square minus 4d d dash plus d dash square. What is the function? Function is 16 log x plus 2y. So 16, I can write here 16 log x plus 2y. So what is the value of a? The value of a, that is 1, and value of b, that is 2. Okay. You cannot write, you cannot put the direct value of a and b instead of b and b dash, because denominator becomes 0. See, a is 1. So 4 into 1, that is 4 plus 2 square, that is 4. So 4 plus 4, 8, and middle term is minus 8. So 8 minus 8 becomes 0. So that's why definitely you have to differentiate, okay, with respect to d. So that is 8d minus 4d dash, okay, log x plus 2y. Now once again, you cannot take the value of a and b, because again the denominator becomes 0. See, the a is equal to 1. So 8 minus 4 into 2. So 8 minus 8, that is equal to 0. Once again your denominator becomes 0. So again you have to multiply with x. So that is x square 16, and differentiation of 8d minus 4d dash with respect to d. So that is 16 by 8 log x plus 2y, and 16 by 8 I can write here 2. So now the final answer is 2x square log x plus 2y. So in today's lecture, we discussed about our case 4. Case 4 is g of ax plus by. Okay, and for this type of example, how we can solve particular integral, that is our main concept to understand. Okay, so thank you.